So we continue on the chapter 5. Today we're going to talk about the second section, binomial distribution. So in this section we will focus on three objectives. So the first one we're going to learn what is the binomial distribution and how can we find the probability in this distribution. Of course, we will learn how to find the mean value and the standard deviation. So we should learn how to find the parameters in this special distribution. Of course, they have the special formulas. So another one is we still need to use the probability to interpret, to determine if a value is significantly high or significantly low. So first of all, let's talk about what is binomial distribution and what are the requirements for binomial distribution. So first of all, we talk about the procedure has a fixed number of trials. So the trials is fixed. And each trial should be independent to each other. So that means the outcome for each trial does not affect the probability in another trial. So that's called independent. The third requirement is all the results, all the outcomes can only be classified into two categories. So we can say success or failure. So all the outcomes can be only sorted into two categories, failure, success. The last one is the probability of a success in single trial remains the same for all trials. The success probability for single trial remains the same for all trials. So that's the last requirement. And let's check some notations for this distribution. So here, S, capital letter S stands for success and the capital letter F stands for the failure. So S and F denote the two possible categories for all the outcomes, but it's not necessary to be a good thing for a success or a bad thing for a failure. It just wants you to understand we only have two kinds of outcomes. And let's check this one. PS. The probability, the capital letter P means the probability. Probability of success. Here, in binomial distribution, we have another notation. We call it the lowercase p. So here, we do not use PS. We directly use lowercase p. Make sure you understand this lowercase p means the probability of a success. So for each trial, the probability of a success is the lowercase p. Similarly, we have another new notation called the lowercase q. It's just 1 minus p, and the meaning is the probability of a failure. So for a single trial, the probability of a failure, we do not use PF in this distribution. We directly use lowercase q. But make sure you understand the relationship between P and Q. So lowercase p plus lowercase q is equal to 1. So if we know the probability of a success, we automatically know the probability of a failure. Similarly, if we know the probability of a failure, we automatically know the probability of a success. So the fixed number of trial is still n. The fixed number of trial, it's n. So here we have the x. X means total we have n trials, right? Fixed number trial, we have n trials. X means the number of successes. X means the number of successes. Of course, it can be a number, any whole number between 0 and n. So for example, if n is equal to 6, x is equal to 3. That means in these 6 trials, 3 are success. 3 of the trials, we get a success, which means the other 3, we got failures. So the probability, again, it's just the same notation. Probability of success, probability of a failure. So here, px, for example, in our x equal to 3, or we can directly write like p3, which means the probability get 3 successes out of these 6 trials. Exactly 6 successes in 6 trials. So just like I said, the success is not necessarily good thing, or the failure is not necessary to be the bad thing. Only want you to remember it's 2 kinds of results. Only 2 possible categories. But make sure you understand here, x always means the number of successes, and the p always means the probability to get 1 success. So these 2 notations should be always consistent. They are always related to success. X always means how many success do we have, and the p always means the probability of a success. Let's check this example. So 1 adult is randomly selected. So we already have a probability. This is the probability, right? 0.85. And we know this is the probability the person knows what Twitter is. Knows Twitter. Suppose we want to find the probability exactly 3 of 5. So we have 2 numbers here. Exactly 3 of 5. So what are these 2 numbers? 3 means x equals 3. 5 means we total have 5. So 5 is our number of trials. 3 out of 5 randomly selected adults know what Twitter is. So know Twitter is the success here. Know Twitter means the success. Know Twitter, which means the probability a person know Twitter is our lowercase p. What is a lowercase p? It's the probability getting a success. So we have the lowercase p. So first question is about, is this procedure result in a binomial distribution? So if it is, second question, if it is a binomial distribution, so we should find what is n, what is x, what is p, what is q. So first, let's check if the result will be a normal binomial distribution. How can we check it? We need to check all the requirements are satisfied or not. Remember, we have 4 requirements to test if the distribution is a binomial or not. The first requirement is about the number of trials. The number of trials is a fixed number or not. So in this case, we know we total have 5 persons, right? We want to exactly 3 of 5 randomly select adults. So the number of trial is just 5. So we randomly select 5 adults. So the number of trial is fixed, is 5. So the first requirement is okay. Let's check the second one. The 5 trials are independently. Of course, the probability of one person no Twitter will not affect if any other one no Twitter or not. So the results are independent to each other. If I randomly select one person, if this person knows Twitter, will not affect the result of other people know the Twitter or not, right? Because each selection is independent. Let's check the third one. So all the outcomes can only be sorted into 2 classes. So here, if I ask a question, if you know Twitter or not, I will only get 2 kind of result. First result if it's a yes, maybe. Another one is only no. So we only have 2 kind of possible results, yes or no, or success or failure, right? So the third requirement is also satisfied. Let's check another one, the last one. So we know there is a probability 0.85 one person knows the Twitter is, and I think the probability remains the same for each people. So the last one, the probability of a success remains the same in all trials. This one is also satisfied. After we check all these 4 requirements, we know all of them are satisfied. Then we can say, yes, the result follows a binomial probability distribution. So if this is a binomial distribution, then we can figure out all of the values we need. So just like I said, we already know the n, and in fixed number, we total select 5 adults. So n is a fixed number, n is 5. How about x? X, we know, we want to know the probability of exactly 3. So exactly 3, it's just a single value. So x is equal to 3. Sometimes x is not a single value. For example, we'll say at least 3, then x is not a single value. It should be x greater than or equal to 3. But here, it's exactly 3. So x is a single value, is equal to 3. So another 2 values we need to know is the probability of success. So from the question, we automatically got that probability. So that's the probability the people know what Twitter is. So here, we treat no Twitter as a success. Then the p, lowercase p, will be the probability of the people know what Twitter is. It's 0.85, right? Of course, we know the relationship between lowercase p and q, so we know if we know the p-value, we can use 1 minus p to get to the q. So in this case, 1 minus 0.85, we will get 0.15. So the most important part, you should check both x and p should should refer to the same concept of success. In our example, the success means knows Twitter. So the X means how many people knows Twitter, and the lowercase p means the probability of people knows Twitter. Always refer to the same meaning of success.